In this lecture, we'll learn how to find the gradient of a line and also the equation of a line. Let's say we are given 2 points, point A being minus 6, negative 3, and point B being positive 4 and 5. Now, when a point is written in such a manner, the first coordinate is that of the x-axis and the second coordinate is that of the y-axis. So here these are our coordinate axes. This is y-axis, the vertical one is always y, and the horizontal one is x. Now these are basically two number lines, and this is their common point 0. And the values of x right from the 0 are positive, and the values of x left from the 0 are negative, and the values of y above the 0 are positive, and the values of y below the 0 are negative. So minus 6 minus 3 minus 6 or negative 6 will be somewhat here, and negative 3 will be somewhat here, right? So this will be our point A, which was negative 6 and negative 3. Now on to point B, that is positive 4 and positive 5. So positive 4 will be 1, 2, 3 and 4, somewhat here, right? These are not actually to the scale, so in the scale diagram we might get a different line with a different angle, and this is, let's say, 5. So this is our point B, which was x coordinate of this was 4 and the y coordinate of this was 5. So our line AB is this, right? So now what if we are asked to find the gradient of this line? Now gradient is simply measure of slope. Now slope of a line is basically its rise divided by its run. So it will be rise over run. This will give us the degree of the slope. This will actually give us the change in y with respect to a unit change in x, and that is only possible if you use this formula, change in y or change in x. So if I write it in the general notation form, we'll get y2 minus y1, this is the change in the y-axis or the y coordinate, over x2 minus x1, the change in the x coordinate. So let's suppose this is our x1 y1 and these are our x2 y2, or we can do it vice versa, we'll get the same answer. So plugging these y2 y1 and x1 x2 in this equation, we'll get negative 3 subtracted by 5 over negative 6 subtracted by 4. So we'll get minus 8 over minus 10. So this negative sign will cancel out this negative sign, will get 8 by 10 or we'll get 4 by 5. Now this is the value of the gradient of the line AB. Now this indicates that the slope is increasing. By saying that, I mean that the change in the value of x of y is increasing per unit change in the value of x. If we would have a line, let's say in this direction, now this line indicates that the value of y is decreasing with respect to the increase or the change in the value of x. So these lines which are in this direction, which are going downwards, they have a negative gradient. Gradient is denoted by the alphabet m, and these lines are going upward have a positive gradient. Because what is gradient? Gradient is simply a measure of slope. Now here we found the gradient by doing y2 minus y1 or x2 minus x1 for the line AB. What we actually did is, first of all, we found its delta y, change in y, by doing y2 minus y1. Then we found its delta x, which was by doing x2 minus x1. Now as you can see that this is somewhat of a right angle triangle. So the angle theta, let's say this is our angle theta, this. So gradient of a line actually gives us the value of the tangent of this angle theta, tan theta. So by doing this, we mean that tan theta equals to m, or y2 minus y1 over x2 minus x1. So if you have a gradient, you can actually find the angle of the line that the line is making with its horizontal. Alright. Now on to finding the equation of a line. Now to find the equation of a line, you need the gradient of the line and one point on the line. Anywhere it may be, but it must be on the line, any point on the line, right? And you can use these two formulas. You can use either one of them to find the equation of a line. You get the same answer. Now if you start on with the y minus y1 formula, for this formula you need one point on the line and a gradient of the line. So let's suppose we take our a was minus 6 and minus 3. Now let's suppose I put this at x1 and put this at y1. So this will give us y minus negative 3. Our gradient of the line was 4 by 5 x minus negative 3. If I solve this up, I'll get y equals to 4 by 5x plus 1 by 8. Now it is a common practice to make y the subject when you're finding the equation of a line, because this actually gives us the general form of the equation of a line, which is y equals to mx plus c. This one. So this general form of the equation tells us the gradient of the line, which is 4 by 5, as you can see it is correct, and this is the y-intercept of the line. This is the point where the line crosses the y-intercept. Hence this is the point where the x-coordinate of the line is 0. Only then it will cross the y-axis, right? So let's use this formula to find the equation of a line, which is y equals to mx plus c. For this you also need one point of the line and a gradient of the line, right? So let's suppose a is my point on the line, negative 6 and negative 3, and we know that gradient is 4 by 5. We're finding the same equation of the line, right? So y is here negative 3, this is 4 by 5, and this is negative 6 plus c. Solving for c, you will get negative 3, negative 24 plus 5c over 5, right? So negative 15, negative 24, positive 5c. If I bring this here, I'll get 9, positive 9, 5c, and c is 9 by 5, which is 1.8. So in this equation, what we did is we put in the coordinates of a point, which was a. We would have also put the coordinates of the point b, and we will get the same answer for that too. So the coordinates of the point a, we put those in this equation, which were negative 6 and negative 3, and no gradient, and we found its y-intercept. Now we'll write it in the general form, which is y equals to mx. M is a gradient, which is 4 by 5 x plus c, which is 1.8. See, the answer is same, right? We got the same answer, but the procedure was a little bit different. For this, we needed a point on the line and a gradient of the line, and we solved it and make y our subject to convert the equation into the general form of a line. Then for this, we put the coordinates of one of the point on the line and gradient of the line, and we found the y-intercept of the line. Then we put the y-intercept in the general equation of the line, and the gradient of the line also in the general equation of the line, which was y equals to 4 over 5x plus 1.8. So that's how you find the equation of a line.